neurotransmitter is released in the 6 steps at the synapse. So basically, most of the psychological effects of drugs happen at one of the 6 steps at the synapse. So what you have is drugs will either be an agonist, which will facilitate or mimic the action of a neurotransmitter, or the drug would be an antagonist, which would block the action of the neurotransmitter. Drugs can be an agonist for one neurotransmitter while simultaneously being an antagonist for another neurotransmitter. So when we say a drug has an agonistic effect on dopamine, it's saying that basically it's making dopamine work harder. And if we said it has an antagonistic effect on serotonin, then it's saying that it's not allowing serotonin to work. But most all psychological effects are coming simply from altering one of the neurotransmitters. So nearly all addicting drugs work on the neurotransmitter dopamine. As we learned, dopamine is our molecule of pleasure, and so the addicting drugs tend to work on dopamine. Also, an area of the brain that's highly associated with addiction, oops, that says addition, sorry about that, addiction is the nucleus accumbens. So I have a picture of that on the next slide. Let's just make sure that you had time to write down that addicting drugs have a tendency to work on dopamine. When we went over the neurotransmitters, I believe I had already put that in your notes. And then you can write this word, nucleus accumbens, but it's going to be on the next slide. Well, it wasn't on the next slide. So this is dopamine right here, and then we talk about that you just add one more bond right here, an oxygen hydrogen to get the norepinephrine, and then here you've got one more. So if you remember, what are these called? The dopamine, norepinephrine, epinephrine? Do you remember what those are called? They're called the catecholamines, and we related a lot of behaviors, like why we do things under stress, why we seek pleasure when we're instant gratification when we're under stress, and we have a hard time planning for the future, and we make big mistakes when we're under stress, is because stress will deplete these, and so you need more of the dopamine in order to make more of the stress hormones to deal with your crisis. Okay, here's the nucleus accumbens, this area right in here. So this is the area that's associated with addiction, the nucleus accumbens here. I think I have other pictures, yes. So again, here's the nucleus accumbens right here, like a slightly different view. And then here it's showing it, and this purple pathways are showing lots and lots of dopamine. This is the dopamine pathways. Okay, so now what we're going to do is we're just going to learn basically about drugs. Then we'll go back to the first slide and show how they work at each of the steps at the synapse. Okay, so LSD is by tabs. It's like on a litmus paper. It's the most potent hallucinogenic substance known to man to date. It stimulates serotonin receptors. I think that I have like a little video at the end to show you about it. It comes from this fungus that grows on ergot rye. There was a scientist that was trying to find out about the fungus and its effects, and in order to cure a disease, I can't remember what it was, but then that's how we found out about LSD. So the way that you could remember is, I think you remember that serotonin stimulates sleep. So LSD kind of produces a dream state where you're seeing all kinds of patterns and things even when you're awake. So maybe you could remember LSD, S for serotonin, and you could remember that it produces visual hallucinations. Now, for me, this definitely wouldn't be something that I would be into, because do you know that the LSD trip lasts for 24 to 36 hours? So basically you're hallucinating for 24 to 36 hours. I tend to be a little bit of a type A personality. I like to be busy doing things, so the thought of just hallucinating for 24 to 36 hours just definitely does not appeal to me. I think I would much rather be reading a book. But who knows, some people, may enjoy that kind of thing, but I didn't know if all of you knew that it lasts for quite a while. Okay, here I'm showing you how, as you can see, this is the serotonin uh, molecular structure, and then you can see that you have this very similar. So we talked about a lock with a key, and so basically a drug goes in, fills the key, or a neurotransmitter attaches to a receptor, acts like a key and opens it. And as you can see, this has some similar properties to it, so it would be able to also fill that space and lock the key. But it wouldn't be able to open the door the same way as serotonin, but it could fit into the lack of serotonin. Okay, mushrooms are another hallucinogen. These are going to create a much more mild effect than the LSD. So psilocybin stimulate the serotonin receptors like the LSD does, but these are going to produce like a more mild, like seeing patterns of colors rather than a lot of visual hallucinations. Like with LSD, you kind of get a web pattern is very common that people report, and patterns, whereas the mushrooms people report, there's more changes in colors of light and as opposed to the patterns. Also, the mushrooms are only going to last around 6 to 12 hours as opposed to 24 to 36 hours. So again, the psilocybin from the mushrooms is going to stimulate the serotonin receptors. PCP is a different hallucinogen. So we've talked about LSD, we've talked about psilocybin. Those are two hallucinogens, and they're both working with serotonin. PCP is working with glutamate. So as you know, glutamate is the most common neurotransmitter in the brain, and so actually PCP is known as one of the most it has actions in so many different parts of the brain. It's the most complex drug. That's the word that I was looking for, the most complex drug. So PCP is going to produce a hallucination, but it's not working on serotonin, it's working on the glutamate. So what people say with PCP is that it produces more of a body sensation. So with serotonin in the mushrooms, you're kind of seeing things, and that makes sense because when you're in a dream state, the dream states are visual. But with PCP, you're kind of experiencing an out-of-body state. Like some people have told me that they were driving in their car, which under the influence of PCP, that's scary, but they were driving in their car and then all of a sudden they felt that the car turned into a rocket ship and they saw themselves going into outer space. Other people have said that they are on PCP and they like leave their body and they are kind of hanging on the ceiling watching their body down below. Now let's talk about this great strength that people think is associated with PCP. People on PCP, they don't tend to be very violent. I know that the Rodney King case begs to differ, but what happens is with PCP is their senses are heightened very, very high. And so, for example, if you put a flashlight in someone's eye when they're on PCP, they don't just see it as a flashlight in their eye. It's as if this huge, incredible light is just kind of attacking them. So their senses are very, very magnified. So if you say, "Hey, what are you doing?" they don't hear like, "Hey, what are you doing?" They hear, "Hey, what are you doing?" And it's very shocking, and so you get up and it's so startling. They don't get great strength from it, but what happens is their pain receptors are mitigated. So the reason why they can break out of handcuffs or they kind of demonstrate this super strength is because what stops us from breaking out of the handcuffs or what stops us from exhibiting great strength is the pain receptors. So since the pain is blocked, you can break the handcuffs because it's the pain around your wrist that's stopping you from doing that. And trying to lift something that's way too heavy, usually what stops us from doing that is the pain fibers from our muscles ripping when we try to do that kind of thing. Okay, here's cocaine. So cocaine is a white crystalline powder. It's inhaled, injected, or rock-like substance that can be smoked. Crack is made by pressing ammonia or baking soda with water, and it makes these little kind of rocks, and it's really condensing the cocaine into a very powerful, quick. But since it's so powerful and quick, it can cause the addiction very easily. Here I'm showing you how cocaine changes the brain. It says the neurological effects of cocaine can clearly be seen here. The cross sections on the left show a normal brain. Those on the right are that of a cocaine user after 4 months off the drug. The fronts of the brain are to the left in yellow areas show high activity even after 4 months. The user's brain is clearly still a lot less active. So actually what cocaine is doing is it's inhibiting the brain. You would think that, oh, it's such a stimulant that it's stimulating the brain, and it is. It's stimulating the nervous system by actually inhibiting parts of the brain. So by inhibiting an inhibitor, you actually get more a heightened activity, a heightened feelings. How cocaine works is it works at the fifth step of the synapse. It blocks the reuptake of dopamine. So dopamine is supposed to be released, turn the key in the lock, and then be reuptaken. But cocaine, it blocks it from being reuptaken. So since it stays in the synapse, it causes dopamine to work harder. I kind of went over that in another one. So the effects of the cocaine is excitement, alertness, elevated mood, and decreased fatigue.